Let's take a look at ETL and also compare it to a cousin of sorts called ELT. Remember that in a typical data warehousing environment, we're bringing in data from our various source applications into the data warehouse or data mart, and we use a data flow technique called ETL. And remember, ETL stands for either extract, transform, and load, or alternatively, extraction, transformation, and loading. The whole idea behind the E side of ETL, so the extract, is to quickly pull the data from various source applications. Traditionally, we'll do so in batches, so maybe it's every hour, every week. In the old days, maybe it's every 5 minutes, every day. We'll look at various intervals for ETL as we talk about what some of your options are, but we'll do so typically in various batches. So that's why ETL is known as a batch-oriented data flow process. When we get the data out, typically we're going to bring it into the data warehousing environment raw, as in a raw form, so basically errors and all, and we'll eventually patch up the errors, and we'll look at ways we do that. And then remember that ETL brings the data in not directly into the place where users are going to access it for their business intelligence and analytics, but rather into a staging layer. The whole idea, once we've done that, we then switch over to the transformation, and the whole idea there is apples to apples comparisons. So we're going to be bringing in data from different sources, and even though they might have the same function or have similar data, they might actually be stored and represented differently. So products might have different data structures and different setups, same with customers and employees, and they might be coming from multiple sources around the enterprise. What we need to do within the transformation phase of ETL is prepare the data, turn it as uniform as possible before it's loaded into the user access layer. Transformation can be very complex, and later on in this section, we'll look at some of the different transformations that you almost certainly will be doing for data warehousing. And once we're done with the transformations, we're ready to load it into the user access layer. So this is the final stop along this data pathway. And the whole idea is we've prepared uniform data. Now we're going to store it and make it available as soon as we're done for business intelligence and analytics. Now, there's a lot of challenges with traditional ETL. Probably the most significant one, aside from just basic technology, is that you need to do significant business analysis before you store your data. You essentially also need to do significant data modeling before you store your data. So there's a lot of preparatory analytical work that needs to happen before you can just pull data out of one or more systems and then load it into your target data warehouse or data mart environment. Now, one of the things that has popped up in the last couple years, especially with big data and data lakes, is we just flip the order around. So instead of ETL, we extract, then transform, and then load, flip the order around to ELT. Extract the data, load it first before you do any transformations, and then do the transformations later on at the point you actually need them. So when we talk about ELT rather than ETL, what we're really discussing, or what we're really talking about, is blasting the data from the various source applications and external data sources into some type of a big data environment. Typically with ELT, we'll bring in the rawest form of the data, whether it's structured or unstructured or semi-structured. We'll bring it into Hadoop, the Hadoop distributed file system, or AWS S3 buckets, or some sort of low-level storage that we basically don't really care about the actual format at that point, because with the ELT paradigm, we don't need to do all of that upfront data modeling and data analysis. We can just blast the data in, store it as is, and then do the analysis later on when we're ready for transformation and making the data available for BI and analytics purposes. What we do then is, instead of using the ETL servers, which tend to be kind of commodity servers along the way, once the data is in a big data environment, we can go ahead and use all of the computing power there to handle the transformations. And especially when you're dealing with incredibly large volumes of data, that's something that really helps the overall performance in your environments. You may be familiar or may have heard the term schema on read versus schema on write. The whole idea with schema on write means that at the point you create the data and make it available for analytical usage, the schema, the structure for that data has already been set. So the schema is there, then you write the data. Conversely, with ELT, because you are blasting the data into HDFS or S3 or some sort of a lower level storage bucket, you can defer creating the schema. So that's all the analysis and data modeling that you need to do. Defer it until you're ready to make the data available for analytical usage somewhere down the road, not necessarily when you're first ingesting the data. So if you're building just a traditional data warehouse with cubes or relational databases, no big data technology, pretty much you're going to stick with the ETL paradigm. There's certain environments that may want you to do an ELT approach rather than ETL, but typically with traditional data warehousing, we're still doing ETL. If you're building a data lake instead, or some sort of a data warehouse data lake hybrid, that's where you're more likely to be embarking down the ELT path.